So now let's talk a little bit about how radians and degrees are similar to each other. So we know that this distance is pi over 4 radians. Well, from geometry, we know that the arc length right here is going to be the same as the angle measure. So we can actually measure this angle in radians. So this angle measure would be pi over 4 radians, which is the rad button you see on your calculator. You can either measure in degrees or you can measure in radians. So this angle is also 45 degrees. If you look right here, our coordinate axes is 90 degrees. This splits it down the middle. So this pi over 4 radians is equal to 45 degrees. Sometimes they'll put a little r over here to represent radians so that you know you're talking about the measure of radians. So let's take a look at pi over 2. Pi over 2 is just taking this angle and measuring it all the way over to here. So that angle measure is going to be 90 degrees. So pi over 2 radians is the same as 90 degrees. This also, this arc right here, can be measured using degrees. We can call this arc length 90 degrees as well. Pi over 6 radians, let's take a look at that. Let's erase this. And take a look at pi over 6 radians. That's just this angle right here, which we used to prove the coordinate points right here. And we found that this whole angle right here is 180 degrees. And so if we cut it into 6 pieces, we find that this is 30 degrees. So this would just be 30. Pi over 3, we have it just a little bit bigger, and we proved this one as well. And that's just 60 degrees. So we're taking 180 degrees and dividing it into 3, and we get 60 degrees. Now if we go all the way over, this whole angle right here, the angle measure of a straight line we know is 180 degrees, but it's also in radians, pi. 2 pi r, all the way around the circle in radians, is 2 pi, our angle measure is 2 pi, but our degree measure is 360. It takes 360 to go all the way around the circle. Now if we have something like 3 pi over 2, so that's this angle measure. So it's a reflex angle. It goes all the way over here. Well, we know this is 180, and we can add an additional 90 degrees to it. So that gives us a total of 270 degrees. Now it doesn't always work nicely like this, and we have to convert some of our degrees, like say we wanted to convert 13 degrees to radians. Well, 13 degrees isn't easily found on our unit circle. And so what we do is kind of look at how we can convert that. So if you have a unit circle, you want to go around to each of these and write down the degree measure. So converting radians to degrees or degrees to radians. So say we have 13 pi over 9 radians. Now that's not on the unit circle. We didn't divide our unit circle into ninths, and so we need to convert to our degrees. And to do that, we're going to multiply by a special 1. And it's a special 1 you use as a conversion factor. So like for example, you've probably done this before, from inches to feet, where you have 12 inches equals 1 foot. Well, we have 180 degrees equals pi radians. Now that's just knowing that a straight line is 180 degrees, and it's also our measure for pi. It's also our measure of radians, and that measure is pi. So we can multiply this by 180 degrees over pi radians, and that's just a special conversion 1. What that will do is I see my radians will cancel each other out right here, and my pi will, in this case, will cancel each other out. And I'll just have 13 times 180 divided by 9. And so what I did here is I just divided the 9 into 180, which just gives me a 20. And I have 13 times 20, and I still have my degrees. Notice that doesn't cancel out, which is good because I wanted to convert to degrees. So that's 260 degrees. This many radians is equivalent to this in degrees. This one is a little bit tricky. Notice this one doesn't have a pi. If I want to convert 4 radians into degrees, Well, I know that a full circle is 2 pi radians, or 6.28-ish radians, so I don't expect this degree measure to be any higher. It has to be lower than 360. So when I'm doing this, I have my 4 pi radians, and again I'm going to multiply by my conversion factor, and I'm doing that so that the r's will cancel. So I have 180 degrees over pi radians. I'm just waiting for the plane to go by to continue talking because it's kind of loud. And that's pretty good. So 180 degrees over pi radians, and I'm just going to cancel the radians, so my measures make a 1 right here. And then I can go ahead and multiply. 4 times 180 is just 720, my degrees don't cancel, over pi. And I can approximate that by actually dividing it, depending on what I need it for, and that's approximately 229 degrees, which is about what I thought when I think about how many times around the radius will go around the circle. So now say we have something like this, where we have negative 500 degrees. We want to convert that to radians. So we take negative 500 degrees. Now notice we switched places with the pi radians and the 180 degrees. And that's because we want the degrees to make a 1. We want them to cancel. And we want to have the radians left on top, because that's what we're looking for as radians. So then we can go ahead and divide them both by 10 here. And so dividing by 10, I just get 50 over 18 pi radians, and negative. So I want to keep it as a negative there. And that's approximately, if I wanted to figure out how many radians that was, usually this is fine, and probably you would want to reduce it just a little more, maybe divide by 2, so that'd be a negative 25 pi radians over 9. And you probably want to just leave it like that, but if you really wanted to know how many times that radius was going around the circle, negative 8.72, so it's going clockwise instead of counterclockwise. But usually you want to just leave it in this form right here. Make sure that doesn't look like a plus.